Hello, I'm making this video to show off a project I've been working on called Myco. It's an experiment in artificial life. The reason I made it is that normally when you have artificial life projects where you have organisms that have brains, the brains typically run as some kind of neural network. And that makes sense, right? Because brain structure generally involves some kind of computation, which is hard to embed in the normal environment that the organisms live in, so you separate it into a neural network. And you can get interesting results with that, but it's not super realistic because, in real life, organisms' brains and their bodies are obeying the same rules. So what I've been interested in is artificial life worlds where you actually don't make that distinction. And one way to do that is for the world that the organisms live in actually to be made of instructions. There are a number of projects I've seen that work like this. There's one called Salus, which is based on another one called Tierra, but what I'm doing here is actually pretty different because instead of kind of a one-dimensional blob of instructions, it's actually two-dimensional. And to show you what that means, let me start the program. Okay, so what you can see here, this central area, is a view of the world. The whole world is 500 by 500 cells, and what you can see here is, I think, 35 by 35. And each of these two dots, this is a cell. And even though it's displayed as two characters, internally it's just a single byte. The two characters that you see are just kind of a representation of that. So like you can see here, byte, this just is the byte value, and if I were to write byte 100, you'd get a different one here. Okay, so I'm going to actually create an organism with spawn, and you can see it's just displayed as blue, and if I let it go a couple cycles, it's just going over each instruction and executing it. The dot dot instruction doesn't do anything, but if I write something like exclamation mark V, that makes the organism's movement direction change to be downwards. And again, I can write something like this, and that makes it go back up, and I've basically just created an infinite loop, and the organism is just going to go through it until it dies. If I spawn another organism here, I can focus on it to actually see a bunch of information here. The 114, this is just a cycle number. It starts at 0 and it just keeps counting up with every cycle. Hash mark, this is just the number of organisms that are currently alive, so obviously there's only one. Byte value, this is the byte value of the cell under the cursor, so if I move this over to here, you can see that it's 43, and here it's 44. Direction, this is just the organism's movement direction. You can see it's to the right, but if I do this, then it is now up, and if I do that, it's down. AX and BX are just general purpose 8-bit registers that it can use for computations, and flag is a control flow flag. It's 1 bit, it can be either true or false, and you can do like conditionals and stuff based on that. This is a memory array. I haven't really seen an organism use it before, but it's just a bunch of 8-bit cells that it can use to store information, if it wants to, I guess. This orange cell, not orange, this red cell here is the organism's cursor, and that's how it actually interacts with the environment. I'm going to use the run command, which just executes instructions as if it was the organism running over them. So this hash mark right moves the cursor over to the right, and I can move it a few more times. You can also increase the size of the selection with R+. Maximum size is 21, I believe. And you can use R- to shrink that back down. And the reason that it has this is that it can actually manipulate the world this way. So it can do something like CM, which is a copy instruction, and if it moves that over a little bit, it can also run MC, and that pastes it. So that way it can actually interact with the environment and copy itself to other places. Okay, so to show you how you can actually get life out of this instruction set, I'm going to run a couple commands that I already have in a file, and that writes this pattern into the world. So you can see it's a 7 by 7 kind of block of instructions, and there's one organism, which is right here. You'll notice its AX register is already set to 7. That's just something that that I used the run command to set that, and that'll become important in a moment. So I'll just run through how this organism works. First thing it does is it runs the CM, which again is a copy instruction, so it takes its entire body and it just copies it to an internal clipboard. A write means look at the AX register, which is 7. So move the cursor 7 cells over, so that moves it over to there. And the organism actually delays for a few cycles after that because it's supposed to just simulate it kind of taking a while to move that. And then it runs this bm, which is look at this center value and store that to register bx. And you can see it did that, and bx is now 1 because the center value had byte value 1. And then it does flag open parenthesis b, which basically says if bx is 0, then set the flag to true. And bx is not 0, so the flag is not set to true, the flag is still false. Now this is a conditional. If the instruction had been true, if the flag had been true, then it would have redirected the organism to move over here, and then it would have gone down to here and then here. But actually what's happening is it's going to go downwards like normal, as if that instruction wasn't there. Minus equals, this is how organisms actually can replicate themselves. So what minus equals does is it says create a new organism that's in the same place. It has the same register value, same memory array, same clipboard, same location, same cursor, same everything, except that the flag is set to true. So if I list the current organisms, you can see that there's only one, and that's the selected one. But after it runs this, if I list it, you can see that there's actually 2, which again, same registers, same position, same everything, except that if we focus on that other one, notice the flag is true. So since it's running this, since they're both running this question mark right operator, they're actually going to be toggled, and so they're going to move into different places. So here, let's just take a look at this one. This is the clone, and it's going to hit this MC, which is the opposite of the copy one. It actually pastes it over here, so it ends up just pasting its body over there, and that also takes a while to run. And it's just going to hit this and then go into here, and it's just going to start this whole process over here. If we look at the other one, it's executing this A left, which undoes what A right does, and it just moves that back over there. And also that's going to take a while. And then A down, which moves it over here. And then it's performing the same check to see whether this value is 0. Since it isn't, then that doesn't really matter a whole lot, so that just keeps going. And the reason it's doing that, by the way, is that at instruction, it actually kills the organism, and it happens to have byte value 0. So what it's doing is it's checking, is there already a copy of me over there? Because if there's a byte, if there's 0 there, then it's probably been copied. So it can use that to kind of determine whether there's already an organism there, because if there is, it's not going to copy itself there, because that would just be a waste of time. So since that check doesn't really matter, it's just running MC again, which is a paste, and forking itself and just kind of killing. It's dying, and then its clone is going to go into the next one. You can see in the meantime, this other one has already forked itself, and it's about to copy itself downwards. This one's about to copy itself to the right. Okay, so we can see this is just kind of going to grow quadratically. And in fact, let's just set the speed to 100 and just kind of let this go. And you can see they're just going to automatically copy themselves for some time. You may have noticed this instruction being written here. This is what's called a cosmic ray. Oh, and you can see we've got another one here. Cosmic rays are just every cycle. The organism, the world is just going to mutate a couple of instructions at random. So if I write cosmic ray rate, you can see it says 1 time per cycle. And since, again, the world is 500 by 500, it's unlikely to actually interfere with any of these organisms. But that's just kind of a source of randomness that can cause the organisms to mutate. Oh yeah, you can see another one here. So they seem to be doing pretty good so far. Yeah, nothing really strange going on, except for more cosmic rays. Other than cosmic rays, another way that there can be mutations is for there to be a write error, which is there's, I think, a 1 in 100 chance when it writes something that it'll just write the wrong thing. Yeah, like you can see there's a write error here, which doesn't really seem to be doing anything, but that way you also get some mutations. And since these organisms are copying themselves and pasting themselves somewhere else every time, those mutations are actually going to be preserved. So you can see there's 28 organisms right now. I'm going to set the speed to be a little bit faster and just kind of let them go. Maybe a couple thousand generations. So you can see the number of organisms is intended to only grow quadratically, even though organisms sometimes will make 2 copies of themselves, but most of the time they're only going to make 1. So the number of organisms isn't going to grow exponentially, at least at the start. But what tends to happen is either cosmic rays cause the check to fail, the check for another organism to fail, or the organism just, there's a mistiming, and so it determines that there's no organism there, but in the meantime there's one written, and as a result the number of organisms does start to grow exponentially. Oh yeah, here we can see something interesting. The organism actually, it tested that there was an at there, but that just arose due to cosmic rays. So it didn't place something there, even though there should have been a space there. So that's just a minor error, but it doesn't come up that often. Okay, and we can see the number of organisms is still fairly low, but pretty quickly it's going to start kind of spiraling out of control. Okay, we're getting some interesting errors here. Like we're getting weird stuff that really shouldn't be happening. Mutations that shouldn't be there. Organisms copying themselves to places where there aren't any organisms actually running. Okay, so I've let it run for a few hundred more generations, and now you can see what kind of starts to happen. You have these huge kind of chaotic masses of organisms that have just stopped even trying to copy themselves other places and are just replicating themselves in one spot over and over. Pretty quickly, you can also see it's just bumped up against the limit of the number of organisms, which is currently 20,000. I mean, I could set the maximum to be higher, but I just don't have it any higher right now. And so what it will do is, once it's at that maximum, if it tries to create another organism, then it will just kill a random one to make space for it. But the consequence of that is that whichever organism can make copies of itself the fastest, even if those copies don't go anywhere, that organism will just tend to take over the sort of space, and it'll hog all of the slots. And that's kind of the biggest problem I have with that right now. Let's see if I can find the kind of problems of the list. Let's just focus on organism 10,000 and view it. Okay, so you can see this happening. So probably in this one spot there are thousands of organisms. And what it tries to do, you can see the reason it keeps going down is that every 5 cycles or so, it'll just identify any organisms that are exact duplicates, like same register, same position, same everything, and it will just delete the duplicate ones, so that way you don't have like exponential growth all in like a few cycles without any sort of strangeness, any sort of modifications that are going on, but it's not very effective. You can see it's only removing a few hundred every time. So yeah, this is the main problem. After a few thousand cycles, you don't really have any complexity. You just have chaotic behavior with thousands of organisms all in one place that pretty much kill any possibility for other organisms to exist. I have a few ideas for how one might stop this. One is to make it so that organisms will die if they don't move around. So maybe there's some sort of, instead of cosmic rays, you have like food or something that's being placed randomly, and then organisms need to gather that in order to survive. That's one option. Another option is that instead of organisms killing a random organism when they replicate, they kill their parent, and that way you kind of, or if not their parent, then their the closest organism to them, and that way you end up with organisms that need to spread out. Otherwise, they will just kind of all annihilate each other. So yeah, I mean, I hope you found this interesting. If you have any ideas or features that you would want me to add, maybe ways to prevent the kind of garbage that happens right now, I'd be happy to hear them. If you want, I also encourage you to download the program and give it a try yourself. The link to the code is in the description. It's written in Rust. You can download the code and compile it if you want to contribute, or you can just try it out. Right now, the usability is not super great. I haven't documented everything, but there are some documents that just explain the instruction set and the commands. If you want to get a feel for the instruction set, I encourage you to try to write your own replicator, like the one I demonstrated in this video. The one I demonstrated is actually pretty bad. There are a bunch of ways you can improve it. You can make it copy itself in fewer cycles, maybe have it grow in all 4 directions instead of just 2 directions, that kind of thing. But yeah, I hope this was interesting. Thanks for watching.